Alright, welcome back. I had some grand plans on getting a new program set up with this new cool microphone that I bought so you could hear me better. But of course, it never works the first time. So hopefully by Monday I will have more of that set up and it should be easier to hear me and the screen should be clearer. But not today. It was not in the cards. We are going to be talking about, well, first we're going to make sure we have our name on our paper, as well as with all of our labels, because I think we're starting to notice that when we go through old notes and old homework, having the labels on there is incredibly valuable, so we don't have to go through and find out all that old stuff again. This is notes, and we're going to be doing two sections today, 2.6, which I accidentally skipped yesterday, and I believe 2.10. The first section we're going to do is called, we're going to be talking about two properties of addition. And this works with decimals and not decimals, of course, because addition holds true for any kind of a number. But we're going to be looking at it specifically with addition. And we're going to be talking about these two properties, the commutative property, and the associative. Now, the commutative property tells us that when we are finding a sum, changing the order of the addends does not change the sum. So let's write that and then we'll look at what that means. Changing the order of the addends does not change the sum. Oh, another thing, sorry about my little boo-boo on my finger. That's from playing with my 3D printer yesterday. It's all clean and nice, so you guys can't see anything, and it doesn't hurt, so don't worry about me. Thank you for asking, I appreciate it. So what this means is that we can change the order of the addends. The addends are things that we're adding, and the sum is, of course, what we get at the end. So in short, if I write 4 plus 7 equals 11, I can also write 7 plus 4 equals 11. And it still equals 11 no matter the order that I write them in. And this is important for the commutative. I like to remember it as like a commute, like I'm going to work and back, because these guys are kind of moving around. They move around in the problem, because we might end up with something where it's like 1 plus 7 plus 6 plus 2, and we can really write that as 2 plus 7 plus 1 plus 6. It doesn't matter when they move around, and that's kind of a key that we use in algebra. Again, this refers back to our algebra thing that we've been talking about, in that all of these are little clues and hints that we use to start solving equations, so we don't have to use that annoying guess and test way. And if I was going to write this as a rule, I would write it like this. A plus B equals B plus A. And this shows that with any number plus any number, the opposite way to add them works out the same. Or the different order. Not the opposite, because we talked about opposites yesterday. Don't let me use that word. Instead, it's the order that's key. So this is our commutative property. Let's take a look at our associative property. Pull it up on my other little screen so I make sure that I spell it right. And this property says that when finding a sum, changing the way the addends are grouped will not change their sum. So changing how they are grouped will not change their sum. What that means is if I use my little example from above or something similar, I can write 3 plus 2 plus 6 equals, well, that's 5. 5 and 6 is 11. I can also write it as 3 plus 2 plus 6 equals, and then 6 plus 2 is 8, plus 3 is 11. And the key here is that I can move my parentheses around, and it doesn't matter where my parentheses are, as long as they are all adding and subtracting, I get the same number, okay? And if I was going to write this as a general rule, the way that I would write that is like this, using these A's and B's and C's, and it's my favorite way to do it, is I would write A plus B, quantity, plus C equals A plus quantity, B plus C. And this is kind of our key. The way that I remember it is the associative property is like, these two are friends in this one, and then B gets mad at A, so he's like, I'm going to go associate with C now. But it doesn't matter who's associating with who, as long as we are adding for all of them, okay? And this gives us this little motion of, if we combine both of them, I can really move around and associate and put parentheses around whoever I want, and it doesn't matter as long as we are staying with the addition model, okay? So, for example, let's do a quick little example. We're going to be using these with the algebra stuff that we've been talking about, specifically solving for that x, right? So if I write this, 0.14 plus 2.58 equals quantity x plus 1.45 plus 1.13. Okay, so first I can check, okay, everything is being added. So this association and this parentheses are not going to hold me back from anything. So I can go ahead and simplify this first. I can add 0.14 to 2.58, and I'll just do that over on the side real quick. 0.14, 2.58, which gives me 12, 5, 6, 7. So I have 2.72. Equals, now these two, it says I'm supposed to do first, but I can change it to the other direction. So I'm going to do that. I'm going to write x plus 1.45 plus 1.13. I can even get rid of the parentheses if I want to. And now I'm going to add these together. I'm going to do it over here. 1.45 plus 1.13. I've got 8, I've got 5, and I have 2. Notice that, again, I made sure to line up my decimal points, which is always the key when I'm doing this. So now I have 2.72 equals x plus 2.58. Now, we've been talking to solve this. We need to use that inverse property of addition. So I want to get rid of this 2.58. So I'm going to add its opposite, or I can just subtract that and write subtract 2.58. But if I'm doing that to this side, I have to make sure to do that to this side. So I can write just a little negative 2.58 in front, so I can say 2.72 minus 2.58, because I can use my little commutative property to switch them around like this. Equals 2.58 minus 2.58 is 0. I've got x over there. 2.72 minus 2.58. We're going to go over to the side and do that again. Okay, it looks like I'm going to have to do some borrowing. Got 4, got 1, and I have 0. So it looks like I have 0.14 equals my x. And that's kind of some of the tricks that I can use to move all of that stuff around. Now, some of the other questions that they're going to ask you is they're going to ask you to identify which of these properties is being used. So this is kind of nice because your answer is really only going to be commutative or associative, which is kind of nice because I know you guys don't like to write a lot of things for your homework. So let's look real quick. I have enough space for one of these problems. Remember, if you ever want to see more examples, you can always look in the chapter and read those, and they will help you out if you're stuck. So if I write which property is being used, or which property, I can write this. 3.4 plus 5.6 equals 5.6 plus 3.4. Well, it looks like I just flipped them around. They kind of moved, or they commuted. So if I go up and look at my two properties, that looks an awful like my commutative property. So it looks like my answer here. Oh, and look, I forgot to box my answer up there. Terrible at remembering that. I would write commutative. Put a little box around there. Nice. I'm done. And that's kind of how we're going to be doing our commutative and associative properties.